In Chapter 2, we learned about conventional costing systems. Basically, we learned about application of manufacturing overhead to the various jobs. We first computed a predetermined overhead rate and then we applied it to the various jobs. And we used only one allocation basis, such as labor hours or machine hours. And then if a particular job took, let's say, 200 hours and we had a predetermined overhead rate already computed at $2, then we would just multiply it at $2 and say that we are going to apply the overhead to this particular job at $400. So it was a very simple system because we used only one allocation base, for example, labor hours. So that became the plant-wide overhead rate. But now we are going to see that we are going to go beyond that into a fascinating field of activity-based costing, which simply means that we split this total manufacturing overhead into smaller activity cost buckets, and then so it's the same manufacturing overhead, but we put like manufacturing overheads together. We pool and organize them into separate buckets, and then, for example, this is the first one, this is the second one, this is the third one, and then we allocate based on, for example, labor hours here, because that would be the most appropriate thing to do in this case, machine hours here, because this activity pool, this cost increases the more the machine hours, for example, and then we come up with an overhead rate for each activity cost bucket differently. So this is called the activity measure, and these are the activity rates. So basically we are fine-tuning and refining it. For example, this might be based on setup costs. This is something you can read and understand. In 1800s, several centuries back, most production was done by using direct labor. We did not have machinery and automation, so we used direct labor, and therefore overheads were all distributed using direct labor as the activity, as the allocation basis. But now we have more complex systems. We have robots, we have complex machines, and therefore companies do not in general make homogeneous products all the time. Often the products are heterogeneous. That means one company could make different kinds of products and they are not really related to one another in the sense that the manufacturing overheads for each can be very different, and the application basis is also different. So therefore, activity-based costing comes up as a good solution. So department overheads may be driven by many different activities. Machining department, the more machine hours you use, the higher the overhead costs in the machining department. While in the assembling department, the more the labor hours, the more the costs. So therefore, splitting by activities makes more sense. Activities take place at different levels. Activities can take place in the production of just one unit. For example, a very specialized aircraft, when it is being made, it is at the unit level that you have to process the manufacturing overheads and assign it to that unit level special job or that special aircraft. Batch level is when one batch is processed. When one batch of cakes are processed, we need to incur setup costs to make that batch of cakes exactly the way they are, but the manufacturing overheads are unique to that batch of cakes. Product level would mean designing products and the hours of design time. For example, where the company might be designing some special fabric, and it is going to be some kind of a unique fabric that is going to be used in some very unique boutique ladies dresses, and so the designing of that fabric is going to be a product level design, and so we can allocate the manufacturing overheads based on hours of design time. Facility level means plant building, ground upkeep, and it's for that entire facility of that plant where different kinds of equipment are used, and there are different kind of activities going on, but the upkeep of the plant and the ground upkeep might be based on direct labor hours. So here I'm going to demo exercise 3.2 very quickly for you. These are the activity cost pools, which is nothing but estimated overhead cost, for example, all the like costs on labor is put together, and that is $52,000. And then I'm just going to pick another one from the question, but the question has many more. I'll let you finish it. Packaging is $75,000. Now, what is the allocation basis on which you are going to allocate the labor overheads to your unit costs? Well, if it is labor related, your activity measure or the expected activity is 8,000 direct labor hours. So you're using direct labor hours. And then you're saying that for packaging, I'm going to use the number of packages as the measure, and you know that 5,000 packages were done, so or expected to be done. So now the activity rate, which should remind you of predetermined overhead rate, because it's nothing but that, but now you have smaller pools. So the activity rate is, in this case, 52,000 divided by 8,000, which equals $650. And in this case, in the case of packaging, you have $75,000 divided by 5,000 packages, which equals $15 per package. Let us work on question 3.7. Part 1 is the conventional costing system, part 2 is the ABC costing system, and part 3 asks us why are the unit costs different between these two. So quickly let me write down what this question is about. You have M and you have W, two products being produced in a company. The direct material cost is $10 and the per unit, and for W is $8 per unit. The direct labor cost per unit is $3 and the direct labor cost for W is $3.75. And then the labor hours, direct labor hours per unit equals 0.20 here for M and 0.25 for W. And then you have number of units produced is 10,000 for M, 10,000 units produced, and here 40,000 units produced. So W is a high volume product and M is a low volume product. And to make 10,000 units of M, it took direct labor hours of 10,000 times 0.20 because the direct labor hours per unit. So one unit took less than 1 hour to make, and in this case also it took less than 1 hour, but it's 0.25 here and 0.20 here. So let's quickly look at the first part of the question, which is asking us to come up with the predetermined overhead rates and the unit cost per the conventional costing system, given an estimated overhead cost of 336,000 total. So this overheads has to be split between M and W according to the total direct labor hours. How do we come up with the total direct labor hours? We do 0.20 times 10,000. In this case, that is going to give us labor hours of 2,000 total for making M, and in this case 0.25 times 40,000, and that is going to give us the total labor hours to make the product W. So if you add both of these, 2,000 plus 10,000 laterally, you're going to come up with 12,000 hours. This is going to be our total allocation base if you just do it per the conventional system of allocating the overheads based on total labor hours. And so this amounts to $28. And then now if we were to look at unit cost for M, you will come up with material cost of 10 and then labor cost of 3. So material cost of 10, labor cost of 3, plus the unit cost, a manufacturing overhead cost, $28 per direct labor hour, but in this case we are using only 0.20 of that. So this is going to be your unit cost of M, and that is going to be 1860 if we do the math. Now unit cost of W is going to be 8 plus 375 plus 28 times 0.25, and this equals 1875. So this is according to the conventional costing system. Let's now look at what's going on if we use the ABC costing system. Under the ABC costing system, the company tells us that they are going to have two pools. The first pool is labor related cost, and the labor related cost pool across both M and W is going to be 168,000. They further tell us that they are going to have another pool, and that pool is going to have the engineering related cost, and that's 168,000. So in other words, what the question tells us is take this 366 and divide it into two separate pools of 168,000 and 168,000. Okay, and then we'll find two separate allocation bases, and for this labor related one we are going to use the um, labor hours as the allocation base. So it will still be um, it'll still be 12,000 as the allocation base. Here we have computed 12,000 hours, right? So the allocation base will still be 12,000 hours. And in the case of engineering, they give us some new information in the question. They tell us that the engineering design time for M and W are 4,000 hours for M and 4,000 hours for W. Okay, now this is a product level activity. So this total is 8,000 hours of engineering design time. So now we have for these two buckets what is the predetermined overhead rate. For the labor related bucket we have $168,000 divided by 12,000 direct labor hours, and that amounts to $14. And here we have 168,000 divided by 8,000 engineering hours, and this amounts to $21. Now the next step is to come up with what we know as the overhead cost per unit for M and W. So how do we do that? Now labor related at $14 per direct labor hour, and the expected activity is 2,000. So $14 is the cost, labor related cost for the labor cost bucket, and then we know that 2,000 hours is what is being taken by M. So $14 times 2,000 hours is 28,000 for M, and then likewise here for W it's $14 times 10,000. So here you have 140,000. Now so this is how you are allocating your labor related cost to M, 28,000 here and 140,000 to W. Then this $21 of engineering related cost is 21 times 4,000 to M, which makes it 84,000, and then here $21 times 4,000, because the engineering, the question tells us, is distributed equally here as 4,000 and 4,000, so 84,000. So therefore now the manufacturing overheads distributed to M is 112,000 and distributed to W is 224,000. How did I get this? I just totaled these two. Now to come up with the manufacturing overhead cost per unit for W, divide by the number of units of M, for M, that is 10,000 units, and for W 40,000 units. So now you're going to get 112,000 by 10,000, that's 1120 here, and that's the manufacturing overhead cost per unit for M product, and and how did I get that? 112,000 by 10,000, and likewise for W it's 224,000 by 40,000, and that is 560. Now the next step is going to be very easy. All you need to do is take direct material, M, what is the unit cost? Direct material of 10, labor cost of 3, and then manufacturing overhead cost per unit of 1120. For W, it is direct material of 8, labor of 375, and manufacturing overhead of 560. So now the total cost per unit for M has gone up to 2420. Notice this. And for the W, it has come down to 1735. So under conventional costing system, M, which is the lower volume product, only 10,000 is produced of M, they had a unit cost of 1860, but now under the ABC they have 2420. Compare that with W, which is the high volume product. They had only 1875 as the unit cost, and now this has come down to 1735. So the high volume is absorbing lower overheads and the low volume is absorbing more overheads. Why is that? This is because the unit product cost on the high volume product work on W declines under the activity cost based system, whereas the unit product cost of the low volume product M increases. Why? This occurs because half of the overhead is applied now on the basis of engineering design hours under the ABC costing system instead of all of it being applied based on direct labor hours. When the overhead was applied only on the basis of direct labor hours, most of the overhead was applied to the high volume product. However, when the overhead is applied on the basis of engineering hours partially, more of the overhead cost is shifted over to the low volume product. We have to keep in mind that the engineering design is a product level activity. So higher the volume, the lower the unit cost, and lower the volume, the higher the unit cost.